You know, every now and then, a piece of technology comes along that completely changes the game. Today, we're talking about one of those, a computer chip that was an absolute engineering marvel, a huge commercial success, and, believe it or not, a seriously flawed design. This is the incredible story of the Intel 8087. All right, so here's how we're going to break this down. First, we'll look at the need for speed that led to its creation. Then, we'll peek inside this game-changing chip and get into its really radical stack design. But that's where things get interesting, because that idea had a major flaw. And finally, we'll see how this chip, despite everything, completely changed computing. Okay, so to really get why the 8878 was such a revolution, you gotta picture the world back in the late 1970s and early 80s. Personal computers were starting to become a thing, and they were powerful, sure, but they had one massive weakness. They were just painfully slow when it came to doing any kind of complex math. And then, in 1980, Intel drops this bombshell. A single chip that they claimed could do those same calculations 100 times faster. 100! I mean, that's not just an upgrade, that's a complete game changer. A quantum leap, for real. So, right, that's the big question here. How in the world did one tiny piece of silicon pull off such a massive speed up? It sounded like magic at the time, and what people didn't know yet was that this little chip was about to open the door to a whole new universe of software. The real bottleneck was something called floating point math. Basically, any math that involves decimals. And that's like everything, right? It's crucial for scientific work, for 3D graphics, even for simple spreadsheets. And without a special chip to handle it, programs like AutoCAD or even early flight simulators were just crippled. They ran at a total snail's pace. It was brutal. So, what was the solution? It was this little guy, the Intel 8087, the floating point coprocessor. And let me tell you, for its time, this thing was an absolute beast, a monster of complexity, and a total engineering marvel. If you actually look at the chip's design, it's like staring at a map of a tiny, intricate city. You've got the data path, which is basically the factory floor where all the heavy-duty 80-bit math gets done. Then there's the microcode ROM. Think of that as the city library holding all the instructions. But the part we really need to talk about, the most clever and honestly the most controversial part of this whole thing, is this section right here, the stack registers. And just to give you an idea of how complex this thing was, we're talking somewhere between 40,000 and 75,000 transistors packed onto this chip. It was crunching these huge 80-bit numbers. Its 8 little registers held as much data as 40 registers in the main CPU it was helping out. And the craziest part, the whole thing was designed by hand, literally drawn out on these huge Mylar sheets. No computers designing computers back then. Wild. And that brings us to the 8087's big revolutionary idea. See, most processors have a bunch of registers that you can just access directly, call them by name. But the 8087, it did something totally different. It used a really radical design called a stack. So what's a register stack? Well, the best way to picture it is like a stack of plates in a cafeteria, right? You can put a new plate on top, and you can take a plate off the top. But you can't just reach in and grab a plate from the middle of the stack. It's last in, first out. The 8087 worked exactly the same way, but with numbers instead of plates. So here's how that works. When you need to work with a number, you push it onto the stack. A little pointer inside the chip just moves down one, and bam, your number is stored on top. When you're done with it, you pop it off. The whole theory behind this was that it would make programming complex math equations way simpler, more elegant, and super efficient. That was the dream, anyway. But, and this is the big twist in the story, this super clever, innovative design, the one thing that made the 8087 so special, was also hiding a massive, almost tragic flaw. It turns out its greatest strength was also its absolute greatest weakness. So you had this massive gap between the promise and the reality. The stack was supposed to make designing compilers easier, but programmers found it incredibly awkward to use. It was supposed to make code more efficient, but it actually created more of a traffic jam to the computer's memory. And worst of all, this supposedly elegant idea introduced a huge danger, the dreaded stack overflow. I mean, it was so bad that one of the chip's own architects, William Kahan, basically said, yeah, there's no reasonable way to fix this. And you know what caused it all? A simple, almost unbelievable miscommunication. The design team in California assumed the engineering team over in Israel was handling the software fix for stack overflows, and the team in Israel assumed the team in California had it covered, so nobody did it. And by the time they figured this out, the chip was already being manufactured. Whoops! And the fallout from this was pretty bad. See, the stack only had room for 8 numbers. If you tried to push a 9th number on top, the pointer would just wrap all the way around to the bottom and overwrite your first number. Gone. The chip would throw up its hands and signal an error, but because of that whole mess, there was no good way for software to catch it. So what happened? Programmers ended up writing all this awkward, clunky code just to make the stack pretend it was a normal set of registers, which completely defeated the entire point of the clever design in the first place. So let's just recap. You've got this brilliant, revolutionary chip with a crippling, fundamental flaw right at its core. I mean, this should have been a total disaster, right? But somehow, against all the odds, the 8087 became a massive success. It's one of tech's great underdog stories, for sure. And it was an underdog even inside Intel. Almost nobody there believed in it. Management was so sure it would fail that the lead architect, John Palmer, made this incredible bet with them. He said, look, I'll work for free. Just write down how many you think you'll sell and give me $1 for every single one you sell over that number. Of course, they didn't take him up on it, which is lucky for them because it would have made him an incredibly rich man. Yeah, even Intel's top engineers in the US thought the chip was way too complicated and probably wouldn't even work, so they passed on the project. It was seen as career suicide. So who took it? This tiny 7-person team over at Intel Israel, led by a guy named Rafi Nav. For them, it was this huge gamble. High risk, for sure, but also super high reward if they could pull it off. And boy, did that bet pay off. When the very first silicon wafers came back from the factory, the results were not great. They were only getting 2 working chips per wafer. But you know what? 2 is a lot better than 0, which is what everyone was expecting. And from that tiny start, the 8087 went on to become one of Intel's most profitable products of all time. It single-handedly established Intel Israel as a world-class design household. This success story just kept growing. The 8087 started out as this optional little chip you could plug into your motherboard. But by 1989, it was so essential that Intel just started building its technology directly into the main CPU, the 8486. Sure, by the 90s, that flawed stack design was finally put out to pasture and replaced by something better, but the core of the chip, its mathematical soul, that lives on. And this, right here, is the chip's true, lasting legacy. Because while that whole stack idea was a flawed experiment, the way the 8087 actually did the math was so perfect, so incredibly well-designed, that it became the worldwide standard. It's called IEEE 754. And that standard is the reason that your phone, your laptop, your car, literally almost every digital device in the world can all agree on how to handle decimal points. The brilliant soul of this flawed chip is still with us today in everything we use. So the story of the 8087 is just this amazing lesson, right? It shows that even a flawed masterpiece can change the world. And it really makes you think, what about the technology we're all excited about today? What's the perfect idea or the hot new thing right now that might be hiding its own critical flaw, its own little miscommunication that we just won't see for another 10 or 20 years? Something to think about.